Hey guys, welcome back to Skyblock. In today's episode, we will be looking at how we can create blocks. Because we can delete blocks, but creating blocks is slightly different because more than knowing what block we want to interact with, we actually need to know exactly what position we need for the creation of the new block. And that's the hardest part of this episode. So for the logic, we have to solve this problem. Okay, how, when I interact with this block here, how do I know if I should create on the east, on the south, or on top of it? There are many solutions for that, I believe, like pretty much like everything anyway. But I came up with one solution, and that solution is to change the way the collision of the item works in order to create different collisions for this side and this side and this side, basically. So when you interact with the block, you will actually check what collider you're interacting with. And based on the information of what collider you are interacting with, you do know if you need to increase on the south or the east or whatever. That's the point. First thing first, let's start simply by creating a new input, which is going to be the right click input. So we're going to add this and choose the right click, right mouse button. Is it good? It's good. Okay. Now in our player script and the Raycast script, we can add a new thing in there, which is if the input is an action just pressed, and it's going to be right click. And here we want to do something in particular, and really we want to do exactly the same thing as here. We want to use a request from the block. Okay, so let's jump to the block right now. Let's create a function interact right click. And this is where we actually want to add the creation block thing. So creating a block at the moment is in the world script. Okay, so in the script of our world. So we have two options, which comes directly to my mind. The first one is to make the world give every block it creates a reference to the world so that they can basically request a block creation. That's one thing. We could create signals from blocks where they could say, I want a block created at this position eventually. Or we can actually make the world a singleton so that it can be accessed by the blocks from outside of it. And that's what I'm going to choose. I will make this a static variable reference world, and I will create an init script where if we have no reference is going to be self. Otherwise, we're going to free the world because we only want one. So now that the world is a singleton, we can go back to the block. And when we interact right click here, we can choose to go world, reference, and create a block. And here, let's just create a very simple thing, which is going to be 5 by 5. Okay, so we're going to create the block number 4 at the position 5 by 5. But the thing is, well, no matter what block we click on, it will create a block here. So if we start the game, we should see that block appearing. Well, not yet, because in the player Raycast script, it does nothing. We do need to open the collider as block and interact with right click. We must do that. So here, if we right click something, we have a block which spawns in here. So there's a slight problem, which is like we can basically click as much as we want and it will keep spawning blocks, right? So this is a problem we will not deal with right now. And we will actually take care of the more important things, like we'll actually have the block spawn right next to the block we clicked on. And here we do have a first problem. If we want to know what is the position of the new block, we first need to know the position of the previous block. So right now, the position isn't inside the block script. So we have the option to go with creating a position vector3 property like this, so that when we create a block, we can go in the world and say node.position is equal to the position of the block. That's an option. However, this would add a vector3 to all the blocks we create in the game, and it might not be necessary, because if you remember, when we created the world, in the remote view here, if we see the world and the blocks in it, they are named based on their coordinates. So this is how we will get their coordinates, by checking the name of the node, basically. So let's see. Back to the block scene. Here, I'm just gonna create a new request, okay? Here we have right click, so I'm just gonna create get world position. And this will return a vector3, which is the position of our block. So first, let's return vector3 0, 0, 0 to avoid errors. And I'm going to show you something. We have the name of the node. And that name is a string, okay? So let's go in the string object from Godot. When we have a name with a specific separator, like the underscore, we can slice the string based on that slice character. And more specifically, we have the method getSlice, which allows us to separate our string based on a specific separator, and then to get a specific element in the list of separated items. So here is the example. With slashes, we define that this is the separator, and then we look for the item index 2. So 0, 1, 2, the index is example. Back to our block, we will have the exact same logic. So here, name is equal to something like, let's say 5 to, well, not like this, but 5 to -2. So the slicer is going to be the underscore, and we are going to have 0, 1, and 2. Okay, so these are the coordinates. So let's create a variable, let's say x as an integer, and this is going to be an int cast of the name.getSlice. The separator is going to be underscore, and the index is going to be 0. And do we need, yes, we do need another parenthesis. GetSlice, no, that's here, I believe. Yes, there we go. So here is the x value, and now we just need to do the same thing for y and z. So now we just return x, y, z, and now we do know the exact position of the block without actually creating a vector3 for each block in the game, which is cool. So now that we do have access to the position of the block, it is necessary to know what side of the block we clicked or we interacted with so that we can increase the coordinates accordingly. So as I said, I want to go with the route where we change the collision of this block. So let's get rid of the block, okay? And let's get rid of the collision altogether. We'll create new collision elements. And here let's first see how we will work with coordinates. So let's create a collision shape 3D. Collision shape 3D, which is going to be east collider. Okay, east collider, and we're gonna create a new convex polygon shape. The point here is I do want to create a kind of a pyramid where the base is going to be the face here, and then the point will be the center of the block. And each face will have its own pyramid with the point at the middle. Here is the east face. Okay, so it is the red axis, positive is north, and this is east. So we do need the coordinates of those 4 points as well at the center of the block. So east collider, back to that, we go to that convex polygon, create an array, and we're gonna leave 0, 0, 0 because that is the center of the block. Now for the first point, let's go with this one. So we do know that all the points are half a unit on the z-axis. So all the points are going to be 0, 5. And then for this guy up here, we have positive red and positive green. So that is again half red, half green. And now we're gonna circle. So still 0, 5. Red is the same. And we go negative for the green one. Okay, now again, we keep circling. So 0, 5 for Z. Green still negative, and red is negative as well. So we have negative, negative. And for the last one, still we have Z, 0.5. And here, green is positive, and red is negative. Okay, so if we do hide all those faces, we see that we do indeed have this pyramid pointing at the center. So now let's duplicate this, okay, and have this a Thous collider. So we could again define all the positions, or we can apply a transformation, which is a rotation. So here we do want to rotate on the green axis, I believe, like this. So 90 degrees, and we want to keep circling. So we will have west collider, well, west collider. So again, we will circle like this, and we keep turning around. Now we need to create the top collider. So top collider, we probably need to change this blue axis. And finally, we have the bottom collider, and we go all the way down, turning the textures to visible. And we finally have all the colliders for our block to interact with. So what now? How exactly do we know which shape was collided with? This is Raycast's duty. So we can open the documentation of Raycast, and in the properties we have the get collider shape. So what get collider shape does is that when we interact with a static body, well, a colliding body basically, it will see which of the colliders, which shape from all the shapes within that body it has hit. So here, get collider shape, it returns an integer based on the ID of that shape. So here we have 0, 1, 2, 3, 4, 5, pretty much. So in our Raycast script, when we interact with right click, we want to send the get collider shape, basically. So here we will send get collider shape. So this is an integer. However, this doesn't take any arguments, so let's just have a shape. ID, integer, and there we go. So let's remove this line, or actually we can leave it. And first we will have this world position as a vector 3 equal to get world position. Okay, so we get the world position, and now we want to apply a transformation to that world position based on the shape ID. So here we have 6 situations. So when we have this kind of thing, instead of just having if this do that, if this do that, we will instead use match. Match will read one variable, and it will have different outcomes based on different values. So we're going to read the shape ID, okay, and we will have 6 different solutions. So we will have 0, we will have 1, etc. So here are the 6 possibilities. And what we want to do every time is we want to apply a transformation to the world position. So we want to apply a vector 3 to it, and it will depend on the actual cardinal direction. So here the first one, which is the east face, we want to increase the blue axis by 1, which is z. So back to the script, world is increased by 1z. Then with that same logic, let's copy paste. When we want to go south, it is opposite of the red, so it's going to be -1 red. West is opposite of blue, so it's -1 z. North is it's actually positive red, so it is 1 x. And then we have top, which is positive y. And we have bottom, which is negative y. Okay. So now when we create the block, we can safely say that we do want to send the world position. Let's try this. Well, everything's highlighted because I did set this visible. When we right click, it should create a block at the right position, like this. And well, that's it. We're done. I didn't see the end come that fast, but yeah, that's all we will do in this episode because it's already 20 minutes, and yeah, later we will see how to choose what block to create. Let's just check that, yeah, each side is working properly. So yeah, that's cool, and we can delete. Yeah, very great. So yeah, that's it for this episode. We will see in the next one how we can use a quick slot to decide what block we are creating. If you did like this episode, as usual, you can do everything you want to do to help YouTube know that it's cool content, so you can like, leave a comment, all the things. You can join the channel membership to support the channel a little bit further and to have access to some specific videos, which are luxury content for this series. So if you want to learn how to make those leaf blocks, log blocks, that's in the members only video. Also, if you do want to tip me to support me financially, you can use the Ko-fi link in the description. That is always greatly appreciated, no matter the amount. Again, thank you for watching this video this far. I hope you liked it, and I will see you in the next one.